So our next question here deals with the synthesis of meta-ethylphenol starting from benzene. And the challenge that I'll often present to you in one of these aromatic synthesis questions, because a lot of these synthesis questions are relatively straightforward, but what I will often have, and you often see in these types of problems that adds to the challenge, is we have two substituents here, the hydroxyl group as well as an ethyl group. And the main issue is that both of these are ortho-para-directors. But in the product, they're in a meta orientation to each other. And so we have to figure out how to get these groups on while also making them in the proper alignment to each other. Now we also need to think about where these come from. The hydroxyl group, we know we're probably going to make that from a diazonium salt, and that means it's going to come from a nitro group. And so we could think about starting by putting the nitro group on here. And we can do that with nitric acid, sulfuric acid, and heat. From here, we could now substitute another group onto this aromatic ring. And it would go, because of the nitro group, into a meta position. Only problem is we can't put an ethyl group on, because that's a Friedel-Crafts reaction, and we know that a Friedel-Crafts reaction does not work in the presence of electron withdrawing groups. But if we did something such as putting a bromine on, using these conditions, we could then immediately convert that bromine into a Grignard reagent, and then adding ethyl bromide to give us the ethyl group that we needed. From here, we can reduce the nitro group, convert it to the diazonium salt, and finally convert that diazonium salt to the alcohol. And that'll get us there. Now that's not the only way that we could have approached this synthesis question. We could also have done something such as putting the ethyl group on as an acid chloride, Friedel-Crafts acylation, used that to direct the nitro group in meta, and then converted those groups as well. But either of those two methods would work. The key here is just doing the substitution at the correct time so that we know we get the desired and necessary meta substitution.